two notes about the Cournot's model. One thing is, you see this Nash equilibrium idea that, you know, I have a consistent belief, and I best reply to that consistent belief, was actually introduced by Cournot long before Nash solution existed, long before game theory was a subject studied by economists. Okay? So Cournot had this idea about the Nash solution, this consistent belief and best response to that, long before von Neumann and Morgenstern had made game theory a popular subject, long before John Nash introduced the notion of Nash solution. And because of that, actually, recently, some game theorists call the Nash solution concept not Nash solution concept, but they call it Cournot Nash solution concept. So don't be surprised. I think it might be a good way to rename it, because Cournot had the idea long before Nash did for a particular game. Nash had it for general games. So that's one. The other thing is, after Cournot published his work, actually it went unrecognized for quite some time. Years later, another French mathematician, Bertrand, came across his work and said, well, that's not how markets work. Firms do not set quantities and sell at the market clearing price. They decide on prices and sell what is demanded by them. Okay? So he changed the model. Okay? So what we'd like to do is, what would happen in such a game? What would you predict or prescribe in a Bertrand model? Okay? So the model is firms So it's Bertrand's duopoly. Okay, let's again restrict ourselves to two firms. Okay, so the model is there's two firms. Strategy set of each firm is again a non-negative number. I'm not going to write it, but you should always make a habit of writing it. So where a strategy represents the action of firm I, in which the firm sets the price of its product as that number. Okay? Okay? So strategy PI represents the situation where the firm I sets the product, the price of its product at PI. Okay? Again, just like Cournot duopoly, we assume that the firms produce identical goods. Okay? So in that case, and just like in the Cournot duopoly, each firm prefers a high profit to a low one. Okay? So we can again use profit functions as numeric representation of preferences, but this time it's a function of price, not quantity. Okay? So what will we have? What would this function be? Well, it's selling its output at P1, Pi. Okay. How much does it sell? Well, the amount that is demanded from him. So let's write that di P1, P2. This is the quantity of the good demanded from firm I, when firm 1 sets the price at P1 and firm 2 sets the price at P2, minus the cost of producing this quantity. So C of di P1, P2. Okay. Again, so in order to be able to compare the results with the Cournot model, let's assume constant marginal cost. Okay. So this is, and identical, C times di P1, P2. Okay? And just like Cournot's model, let's assume linear demand. Okay? So the market demand is just like before. So Q, P, alpha, alpha. Okay? In this case, what is the demand for the output of firm I? We assume that our consumers are perfectly informed and rational. And hence, what do? You know, I'm selling markers, you're selling identical markers, and we have a whole bunch of consumers. From whom will they buy? From the one who sets the lowest price. Okay? So, what is the demand? So let me write the demand for firm 1. The demand for the output of firm 1 is going to be well, if P2 is smaller than P1, nobody will demand the output of firm 1. Everybody will buy from firm 2. What if P2 is bigger than P1? Then everybody will buy from firm 1, so you will get the whole demand, which is maximum of 0 and alpha minus. Oh, I'm sorry. I forgot. Let me erase this part. Warn me if I write, well, I'll draw a line there. So this part is good enough. So it's going to be the maximum of 0 and alpha minus P1. And then if P2 is equal to P1, then they're going to share the demand. Some percentage will go to firm 1, some will go to firm 2. Let's simplify things and assume that they get equal shares. Again, equality is not important. It just makes life. So alpha times this maximum. Okay? So that's what we have. Okay. So what is the first thing you would do? So we're finished modeling. We know who's involved. We know strategies, actions available to them. We know their preferences over strategy profiles. So what would you do? Look for, so the final aim is first, look for strictly dominant strategies if they exist. If they don't exist, look for dominant strategies. If they don't exist, look for Nash strategy profiles. But for those three, best responses are powerful tools. Okay? So it's a good idea to start by looking at best responses. So come on, do it. So actually, let me write it here. So what do we have? I'll simplify the expression for you. So let's again concentrate on firm 1. Right? That's the profit function. So this term and this term is common. I factored out, so we had pi minus c. That's what we have, and that's the common term. I'm sorry, that's not P2. That's, well, I'm sorry, not complete. let me write it here. Sorry about that. If P1 is less than P2, it's 1 over 2 P1 minus C maximum alpha minus P1 0. If P1 is equal to P2, and it's equal to 0 if P1 is bigger than P2. The good thing about here is that each firm produces what is demanded from them. Okay? So if firm 1 sets a higher price, its output will not be demanded. Hence, its profit will be equal to 0. If its output is not demanded, it doesn't produce anything. So, what can you say about the best responses? Yep.
For example, we know for sure that if
Okay. Write it down. Draw. Show where do you get those things. Again, pictures are powerful tools. Try to make use of them. So we're trying to find the best response. That is, we're trying to solve a maximization problem. Okay? Fixing P2, we're trying to find P1, which maximizes this function. Now, you might think about using differential methods again, but be careful. This function is not differentiable everywhere. Write down. I would like to see the work, the actual work. Where did you get that answer? Based on what? Based on what?
Bertrand's dilemma.
Well, we don't know anything called Bertrand's dilemma at this stage. Where do you get that answer? C is less than alpha, just like the Cournot duopoly. So everything is the same as the Cournot model, except rather than setting quantities and selling at the market clearing price, they decide on the prices and they produce and sell what is demanded from them. So my first recommendation would be pictures are powerful tools. Draw this picture. So you're drawing isoprofit curves? Does the isoprofits look like that? Are you sure? Can you convince your friend about that? First, try to convince your friend. If he's convinced, then we'll try. Come on, come on. You should be able to do this fast. Anybody? Need paper? First, try the easy one. You're trying to draw isocurves? Okay. Getting there, that's a good point to start, but the rest will be complicated. Anybody? You see, this problem has several complications. First of all, the function is piecewise defined. It behaves one way in one region, another way in another region. That's a problem. The other thing is maximization, taking the max of two numbers. That's always problematic. So make some simplifications to start with and draw those simplified versions and then build on it. For example, rather than trying to draw the whole thing, why not just concentrate on this part? Which is still maybe complicated. Why not for a minute forget about the maximum and just take this to be alpha minus P1? Then that function should be a very simple function that you even know from secondary school. What kind of an animal is P1 minus C times alpha minus P1 as a variable of P1? It's a parabola, right? And we know how to draw parabolas. All you have to know is know the roots. The roots are at C and alpha. So that function is like this. Okay. Unfortunately, the function does not always behave like that. Okay. First of all, when P1 is bigger than alpha, this number is equal to, this number is negative, so it is equal to 0. So this part doesn't go like that. It goes 0. You see? Now one down. Now I can put the max back into the picture. Okay? So if I didn't have this part, if I just had, that's my function. I'm done. But now that's not it. The profit behaves like that only when P1 is less than P2. So what do I have to do? I have to put P2 somewhere. Okay, well, what is P2? P2 can be any number from 0 to infinity. Okay? So tell me, where should I put P2? So we'll draw maybe more than one picture. So let's put it here. If P2 is less than C, what happens? Then our function behaves like this blue function, only on the left of P2. So our function will behave like that only on this region. When P1 is equal to P2, what happens? I have a 1 over 2 term, which says, take half of this length. So I'm right over here, right? And when P1 is bigger than P2, what happens? It's 0. Voila, we're done. This is when P2 is less than C. That's it. Right? So, what can you say about the best response of player 1, firm 1 to P2 if P2 is less than C? It's P2 to infinity. The maximum profit that the firm can get is 0. Where does it attain that profit? At any price greater than P2. So far, so good? So far, so good? Okay. Then, well, maybe P2 is not bigger than C, less than C. Maybe it's bigger. By the way, as I told you before, this is like a frame on a movie, a frame in a movie, okay? So when you look at that frame, you should get an idea about the whole movie. When I look at this frame, I get an idea about how the movie behaves for all these P2 values, okay? As P2 increases, these points move like that, okay? And when you look at it, what is the first important point that you see? When P2 is equal to C, right? So when P2 is equal to C, what do you get? You're at this point, and your picture would look like? Would look like this, right? So far, so good? So far, so good? So if P2 is equal to C, then what is the best response of player 1 to P2? Exactly. This was an open interval. Now it's from P2 to infinity, which is the same as C to infinity. So far, so good? Okay. What if P2 is bigger than C? Come on. Write the other frames for us. So that's how our function, if there was no restriction, that's how this function behaves. So where do you want me to put P2? So I'll move and you tell me to stop. Stop. So if P2 is here, what does the function look like? So in this region, it behaves like this parabola. Comes up here. And then when P1 is equal to P2, what happens? Half, it drops down here. And then from that point on, it's all 0. Okay? So far, so good? So if P2 is bigger than C, then what is the best response of player 1 to P2? Sorry?
C,
From C to P2. What is the best response? P2? Okay. P2 minus epsilon. Okay? So far, so good? So far, so good? Ah, I did it again. Sorry about that. I'll draw my line here. So when P2 is bigger than C, then best response of player 1 is equal to P2 minus epsilon. Don't write yet. Okay? Sure. Okay, so you want alpha plus C over 2. So your friend says things will change when P2 passes this point. So let's follow his recommendation for now. Maybe we will not need it, but let's put it. You want equal, less than equal? Well, let's keep it like that, we'll see. So far, so good? So far, so good? How do we decide on epsilon? It will be bigger, right? So first of all, when you look at it, the reason why I wrote it, I'm glad that your friend brought that up, okay? When you have this, everything on the right-hand side should have an explanation. They should either come from the left-hand side or be a parameter of the problem, like alpha is a parameter, C is a parameter. Epsilon is not a parameter. It's not in the story. It's not in the, doesn't come from the left-hand side. So without even knowing anything about, well, optimization, maximization, minimization, I should be able to conclude that this answer cannot be correct. As your friend said, we don't have an explanation for epsilon. Okay, so this cannot be correct. And actually, your friend said, if P2, let's say that we really had a number called epsilon. So we had P2 minus epsilon. Well, your friend says the value of the function at P2 minus epsilon over 2 is even larger. So this cannot be a maximizer. Okay? Because this yields a higher profit. So is this the maximizer? No, because this even yields a higher profit. Conclusion? There is no best response. There is no, this, when P2 is between C and alpha plus C over 2, there is no maximizer. Which is a first. Up to now, we always had best responses, right? And actually, this will continue until, well, even if P2 is equal to alpha plus C over 2, we would have the same problem, so we could put equality here. Now, if we pass that point, what happens? Alpha plus C over 2 will become the maximizer. So far, so good? Again, so 1, 2, 3, 4 frames, okay, 4 pictures should tell us as P2 changes, we see what happens. So maximizer all here, okay. So no maximizer, still no maximizer, and then which I realized I made a mistake here. It should not go down. It should continue with 0. That's a mistake that I made in the graph. It should go 0 here. So from that point on, it should not, this part should not be there. It should be. But you see, 4 frames should tell you everything about this long story. Okay? Any questions? So, what's next? So now we know the best responses. What would you do? Looking at the best responses, what can you say about dominant strategies? Okay, there is none, right? First of all, in order to have a dominant strategy, the intersection of the best responses should be non-empty. It can't be. So there is no dominant strategy. If there is no dominant strategy, there can't be any strictly dominant strategy. So the first 2 solution concepts, we have no hope from. So what do we look at? Nash. So for Nash, what do we want to find? We want to find a P1, P2 star, where P1 star is the best response to P2 star, and P2 star is the best response to P1 star. Okay? So you can either write the algebraic equations and try to solve them, which have several cases, or draw a picture. So please draw a picture. Mm-hmm. Sorry? Is CC. Well, draw it and let's see. So what are the important points we have? We have C, right? And then the next important one is alpha plus C over 2. And let me just mark alpha for. So, best response for player 1. When P2 is less than C, what did we have? I erased it from there, but when P2 was less than C, it was from P2 to infinity, excluding P2. So if P2 was less than C, the best response was anything greater than P2. So we have all these. So if I keep doing this, this is what I will get. And when P2 is equal to C, this time it was, again, from P2 to infinity, but P2 was included. So these are all open, but that's closed. when P2 is between C and alpha plus C over 2, there was no best response, so there's nothing to mark. When P2 is greater than alpha plus C over 2, what was the best response? Alpha plus C over 2. So for any of these prices, there is a single best response, which is alpha plus C over 2. So that's the picture of the best response correspondence of player 1. Okay. What about player 2? Well, because the cost functions are identical, we just take a 45-degree image of that. Okay, so it's going to be just like this. All these points open, except for this, which is included. And then, so that's the picture of P2. Why don't we have a dot here? Well, let's look at the picture. Okay, just give me a minute. So I'll take the frame just at that point. So go. So when P2 is equal to alpha plus C over 2, that was the question, right? What is the maximizer of this function? Again, it doesn't have a maximizer. The closer I get to alpha plus C over 2, the larger the value of the function is, the higher the profit is. But when I hit alpha plus C over 2, profit suddenly drops. So when P2 is equal to alpha plus C over 2, firm 1 does not have a maximizer. But past that point, alpha plus C over 2 is a maximizer. Okay? So far, so good? Okay? So, looking at the picture, what do you see? CC, the Nash solution for this game is each firm sets its marginal cost as the price. Sorry? 0, 0. When firm 2 sets the price at 0, if they set it to 0, what happens to the function? So actually I only looked at positive firms. So when P2 is equal to 0, again, that region. Thank you. So when P2 is equal to 0, then either there's equal, P1 is equal to 0. So you get negative, or P1 bigger than, so it's 0. So what do you get when P2? So P2 is equal to 0. If P1 is bigger than P2, your profit is 0. If P1 is equal to P2, what do you get? So put 0 here, put 0 here. What do you get? Minus C over 2 times alpha, which is a number over here. Okay? So again, your best response is like this. 0 is not a best response. Okay? So essentially what this says is that if your opponent sets a very low price, you don't want to be in that market. Okay? If your opponent sets a price less than C, you don't want to be in that market. You don't want anything to be demanded from you. What do you do in order to do that? You set a higher price. Okay? That also includes 0. Okay? Any questions? Yes, sir. Okay, again, the function Just okay. So we're looking at the maximizer of this function. Does this function have a maximizer? Okay. So see, the closer I get, the larger I am. But the thing is, there is no closest number to P2. The closer I get to P2, the larger the profit is. Okay? So most of you have the impression that I would choose the closest number to P2. When the domain is the whole set of non-negative real numbers, there is no closest number, which things will change if we discretize this problem. Okay? So if prices were allowed to change in multiples of a number, multiples of a lira, multiples of a kurush, multiples of a dollar, it would be a different story. Okay? But with our assumption, when we took S2 to be the set of all non-negative numbers, there is no closest number to P2, which means that this function does not have a maximizer. Okay? So far, so good? So, what happened in the Bertrand model? Firms will set the marginal, the price of the good as their marginal cost, and their profits would be, right? Would be 0. Okay. So that's the conclusion that we get from Bertrand's model. Which, when I look at your faces, it looks a little puzzling, right? For one thing, for many people, just like Bertrand, for many people, when they think about markets, they see firms as price setters, not quantity setters. Most firms, it looks like they set prices and sell what is demanded from them. Okay? But then that's what we get at Nash equilibrium. Okay? So what are the conclusions that we can get out of this? Yes, sir. The demand is?
Demand should be shaped by prices.
By prices, you mean by firms? Price. Well, yes, but that's what we did. But you mean shared, if you were a consumer and I'm selling at a lower price than your friend is, would you still go buy a little from her? Okay, so you would buy from the cheapest one, which is what we have already here.
What I'm saying is decreasing costs may increase the demand.
Decreasing cost, you mean price? Yes, that's what we had in our model also. When you look at the demand function, as prices decrease, quantity demanded increases. That's already what we had in our model. So, what's going on? So first of all, which one is more realistic, do you think? Price setting or quantity setting? Price setting. Yes?
I don't know if I get that right.
Well, I don't know about macroeconomics. Microeconomics. Well, we're doing microeconomics now, so we're trying to decide whether they're price takers or price makers.
Normally, we generally assume that they are price takers, right?
Normally, is that what we assume? I don't. Well, in a perfectly competitive market, we say that prices and quantities are determined by the interaction of market supply and market demand. Okay? So it's not just only one of them, but so I see that what you're doing is in a perfectly competitive market, they don't have any influence on the, well, each firm alone does not have any influence on the price because there's too many firms. So that's what you're talking about, okay? But there's not too many firms here. So that's an assumption that we made in Introduction to Economics, Introduction to Microeconomics in our first year. But that was a very simple model to get things started with. Now we're doing, hopefully getting into more realistic models. Well, first of all, in some markets, firms could be price setters, okay? Like market for markers, market for coffee. But in some markets, they might be quantity setters, like market for apartments. You see, the reason I'm saying this is that when you change the price a little, demand changes. A market producer can, well, not demand, quantity demanded changes, okay? A producer of markers can easily change the number of markers that it produces. A coffee shop can easily change the number of cups of coffee that it produces in a given day, okay? But a house builder, an apartment builder, cannot just say, well, the prices of apartment has increased, so I'm going to double the number of houses that I build today. That's not possible. Or the prices have dropped too low. I'm just going to build the first 2 floors and I'm not going to build the rest. Okay? That's not possible. Okay? So, in markets where it's hard to adjust the quantities, the firms would set quantities, okay, and sell at the market clearing price. Okay? And how do they do it? Well, they usually don't change directly their price. What do? They give different incentives. They give credits at different rates and so on. Okay? They say, we pay the value-added tax. That's a way to lower the price. They don't change the price tag, but they make you pay less. Okay? But in markets where it's easy to change the quantity produced, probably they are price setters. Which is the case for markets, which is the case for coffee. But do you think Starbucks, Coffee Break, Mozart Cafe, they're all setting at the marginal cost? Probably not. So what's going on? Which assumptions led to this conclusion? Same product, right? There was a few number of firms, which is a realistic thing, at least for our campus. Okay? We assumed a linear demand. Well, the result would not change that much if the demand was not linear. But one of the strongest points was that the 2 firms were selling identical products. Okay? And that caused all these jumps and all that stuff. So what would they try to do? They would try to differentiate their products. They would change their cup. They would say 100% natural and this and that. They would do commercials. So what do? They try to get away from this. They try to differentiate their product. So there again, coffee sold by Mozart is a substitute for coffee sold at Starbucks, which is a substitute by coffee sold by Coffee Break. Okay? But they're not identical products. Everybody views them as different. Close substitute, but as different. So what should you do? Time's almost up. What should you do? Start with a more realistic. So change the demand function. They're not selling identical products, but maybe they're selling products which are substitutes to each other. Actually, while you're at it, what you can do is you can also look at what happens when they are complements to each other. Okay? So I'll give you homework about that. If they're complementary goods, would it be the case that they're monopolist? Well, build the model, look for dominant strategies, look for, which they will not exist, look for Nash solutions and see what you get. Okay? One more thing, one more point before we call it a day. The results are dramatically different. Profits are 0 here, and the other one, the profits are positive. The demand was the same demand. The market demand that we used was the same linear demand. Okay? So, when you have this demand, tell me the price, I'll tell you the quantity. Tell me the quantity, I'll tell you the price. There's a one-to-one relation between price and quantity. So when one looks at this, one could think that there is actually not much of a difference between setting a price and setting a quantity, right? But we got very dramatic different results. What happened? Well, I would like you to think about this. the demand, the market demand is the same. But look what the demand for the output of firm 1 is in a Cournot model, and look what the output for firm 1 is in a Bertrand model. That is, write down residual demands in each market. Draw, not write it, draw it, that would be enough. Okay? So I would like you to think about this. Cournot model, Q2 is given. If Q2 is given, what is the demand for firm 1's output? P2 is given. If P2 is given, what is the demand for firm 1's output? So, yeah, I should write, I'm sorry. Q1, P1, Q1, P1. Q2 given, what is the demand? We call that residual demand, okay, of the output for firm 1 in a Cournot model. P2 given, what is the residual demand? What is the demand for the output of firm 1? Draw those pictures. The market demand is the same in both cases. But that same market demand generates very different residual demands. Draw them, see what happens. Okay? We'll talk over the break. That's it. Oh, I forgot the attendance sheet. Anyhow. Okay, that's it. Have fun.